Play the sack, all dressed in black. What silver buttons all down her back. Hi-ho, got tips and toe. She broke a needle and she can't sew. Walking the dog. Yeah, just a walking the dog. And if you don't know how to do it, we'll show you how to walk a dog. Well, come on now, boy. Yeah. Ask your mother for 50 cents. And see an elephant jump the fence. He'll jump so high, he'll touch the sky. They'll get back till the 4th of July. Walking the dog. Yeah, just a walking the dog. And if you don't know how to do it, we'll show you how to walk a dog. Well, come on now, boy. Wow, yeah. Wave a sack, all dressed in black. A silver button all down her back. Hi-ho, their tips and toe. She broke a needle and she can't sew. Walking the dog. Yeah, just a walking the dog. And if you don't know how to do it, we'll show you how to walk a dog. Well, come on. Yeah. Just a walking. Just a walking. Just a walking. And if you don't know how to do it, we'll show you how to walk a dog. Well, come on now, boy. Yeah. If you don't know how to do it, we'll show you how to walk a dog. Well, here, boy. Yeah. Wow, yeah. If you don't know how to do it, we'll show you how to walk a dog.
All right, welcome back. This is, of course, Computer Science 1, CSCE 155E. And today we're going to continue with our conditionals that we started last week on Wednesday. As always, we are on Piazza, so if you've got a question and you're in the room, feel free to go ahead and raise your hand. Otherwise, go ahead and post it to Piazza, and we'll get to it. Otherwise, if you want to, you can go ahead and use the YouTube chat feature as well. Let's see. All right. So, when we left off last time, we were looking at more complex logical operations using the AND and the OR operators. Remember that those have to be both 2 ampersands or 2 vertical strokes or pipes or whatever you want to call them. And you can use this to create more complex conditions. That they have to be a freshman and that they have to be a student or something like that. We'll go through an exercise at the end of today so that you can better prepare for your lab tomorrow, which has something exactly like this, okay? But before we get there, we need to look at some pitfalls and some other things that you can do with basic comparisons. One of those things that you can do is, remember or recall, you cannot, I'll emphasize that, cannot use the equals operator for strings, right? And that's why, because it will compare the memory addresses of the strings, not their contents. And so we went through an example of this where we had hello, 2 strings with the same exact contents, but they were coming up that they were not the same unless the compiler was doing some magic under the hood and got rid of the double memory addresses. But you can use them for single characters. Remember, a single character in C is a char, and to get a single character, you use single quotes. Double quotes are always going to be strings. A single quote is a single character. And why can you do this? Can you do this? Because all characters are ASCII text characters. They are all numbers or have a numerical value, right? Capital A has value 65. Lowercase a has value 67. Lowercase b comes after lowercase a. It has a value of 98, right? I think I said 97 for A, 98 for B, etc. So in C, you can actually go ahead and use comparisons when you're comparing single operations. For example, let's go ahead and do a code snippet here where say that you prompt a user for a question, a yes or no question, right? So printf, are you a student, right? Enter yes or no, right? And what we'll do is we'll go ahead and scanf for their answer. So char answer, and we'll go ahead and scanf percent. What's the placeholder for a character? The one that actually makes sense is C, right? For character, for a single character. Answer, is that correct? When I use scanf, what magic do I have to remember for now? An ampersand. So that person is going to enter in a single character and then hit enter. Or they could mash the keyboard and then hit enter, in which case we would only read the first character that they actually typed. It doesn't really matter because if they don't type it, if they type anything other than Y, we want to reject it and say that they're not a student. Even if they put N or capital N or X or something like that, then we'll just interpret that as a no answer. So we can check for that answer. If their answer is a lowercase y, then we'll go ahead and echo out that they get a discount or something like that. Printf, you get a student discount. Yay. Otherwise, else, printf, same stuff we were doing last week. You pay full price. All right, there you go. What happens if they printed, so this works if it's a lowercase y. What happens if they type an uppercase y? It's going to print, you pay full price, right? So let's go ahead and allow them to either do uppercase or lowercase. To do that, we use what we just covered, a logical OR operation here. Answer is equal to capital Y. There we go. And now we're taking care of both of those possibilities. Capital Y, lowercase y. What about this? Is that correct? Definitely not. What behavior would that get? Everybody would pay full price all the time, because this is a contradiction. The answer can't both be one thing and a different thing at the same time, right? This is one single variable here, and it's either it has to be one single character. It can't be both a lowercase y and an uppercase y at the same time. So you've got to watch out for your logic here. Right? Do I mean an and or do I mean an or? Okay. Some more pitfalls. Right? Pitfalls are things that common mistakes that you should avoid. So consider the following code. All right, let me go ahead and cut and paste this so I had to get it right. There we go. All right, what's going to happen with that code? Let's find out. Let's actually go ahead and print something. Printf. Okay, whatever. All right, I don't know what it does or what it's supposed to do. I'll print out actually true. Otherwise, I'll go ahead and printf false. Oops, there we go. And of course, I need that variable there. Int a is equal to. Let's try some values here. Let's try 5. What would you expect it to print here? So obviously, what I'm trying to do here is, does a lie between 0 and 10 inclusive, right? So 5 is certainly between 0 and 10, right? So it should print true. Let's find out. Demo. True, okay. Great, so the code works. Let's try another value. What about -5? Should it print out true? Not according to my meaning. My intent here is that I want a to lie between 0 and 10. It does not. So logically, it should print out false, right? Let's go ahead and do that again. Still true. Okay, something weird's going on here. Let's try one more thing. 15. Let's go ahead and compile that. Again, it should print out false because 15 is beyond 10. So let's run it. True. This is perfectly syntactically correct C code, but it doesn't, and we understand the meaning of it from the context that you mean, well, if A lies between 0 and 10 inclusively on both ends, but that's not the answer that we get. That's not the behavior that we get. And the reason is, again, the above will compile, execute, and not work for certain values. Right? Why? Well, because of the way that it works. So actually, let's walk through this first. Let's go back to the original value here, -5. Actually, we'll go with 15 here, okay? This is going to be evaluated left to right. So this is the first comparison. 0 is less than or equal to A. Is that true or false? A, remember here, is 15. So it's true. What is true in C? 1, or actually, more correctly, what is false in C? 0. What is true in C? Anything else. So what this is using by default is likely 1. So this gets evaluated to 1. And now guess what? Is 1 is less than or equal to 10? Yeah, so that's why we were getting true all the time. Let's back up and try it again for -5 and reason about that. So 0 is less than or equal to -5. That's false. What's false? 0. Is 0 less than or equal to 10? Yep, you better believe it. So that's why we're getting true all the time. Be careful, right? The correct way of doing this is, give me the corrected code here. If you want a range, what do you need to do? You need to split it up into 2 conditions. If 0 is less than or equal to A, and A is less than or equal to 10. Now, those are 2 conditions that will get evaluated potentially independently. All right. Certainly, logically, though, this will get evaluated. This will get evaluated. Now, remember, I said that the stylistically, that in general, you want the variable on the left-hand side. In this case, though, it would look kind of weird going A is greater than or equal to 0 and then this, right? That looks a little bit weirder because it doesn't tell you what the intent is. This is a lot clearer because I'm trying to go for a range here. If it's between 0 and 10. So I would argue that, yeah, go ahead and break with that style guide that I gave you, because in this particular instance, it is much more readable to do it this way. Okay? But certainly it needs to be correct above all, right? All right. Pitfall number 2. Consider the following code. Int A is equal to 5, and then if A is equal to 10, then we do something. So I'm going to reproduce that over here. Int A is equal to 5. If A is equal to 10, then print true, otherwise print false. What is this going to do? What should it do? What's my intent here? What did I mean to do? If A is equal to 10, so if the value stored in A is equal to 10, then I should print out true. Is the value stored in A equal to 10? No. So I would expect this to print out false, right? True. Why? Stare really hard at it. What did I do? Yeah. Exactly. Equals equals is the equality checking. A single equal sign is the assignment operator. So what happens in this instance is A receives the value 10. Well, the result of that is 10, and 10 is true. Because 0 is false, anything else is true. And so it ends up printing out true. Okay? So, again, the solution is, this is syntactically correct. Again, the above will compile, it'll run, but it'll give incorrect results. Why? Because A equals 10 is the assignment operator. When evaluated, the expression gets the value 10, and so is true. Right? Got to be careful. Always use equals equals for equality. Quality testing, right? Here's another pitfall. Consider the following piece of code. If a equals to 10, so I didn't make the same mistake twice. I'm never going to make the same mistake twice, just like you are never going to make the same mistake twice, right? Once you learn from your mistakes, you're good to go. I just made a different mistake here. Right? So let's go ahead and take this over to my demo code here. And a is equal to 5. Will this print out that a is 10? A is 10. It's not, though. I didn't reassign it. If I printed it out, of course, you could see that the value is still indeed 5. Printf a is equal to 5. A. All right. Compile that again. Ignore that. Oh, so sorry. %d. There we go. Don't ignore that. There we go. You can see that a is indeed still 5. I didn't reassign it. So what's the issue here? Yeah. Good. A semicolon. Does that belong there? Remember that semicolons end executable statements. So let's walk through what the behavior of this function here, or of this code. If a is equal to 10, then do the next command. Well, what's the next command? I'm flashing on it right now. Do nothing. Right? And then end that executable statement. Then the block of code immediately after that is not predicated on that conditional statement, and so it gets executed no matter what. Right? So you've got to be careful. This ends up being an empty if statement. And it's a pitfall that you can get into, especially if you don't use good styling. If you use good styling and always have opening curly brackets and closing curly brackets and are consistent about where you put them, like I'm doing right here, then, of course, then you won't fall into this trap. All right? So the above is wrong because the if statement is bound to an empty code block. Regardless of the value of a, the print statement will execute because it has nothing to do with the if statement. It would be like it would be equivalent to the following, right? That I go ahead and put this on a bunch of lines later, right? And again, that's an empty if statement. It's just like if I had put empty curly brackets here. That's what it looks like, right? And that's obviously wrong because now you've disassociated that block of code entirely. And if you use good style, then hopefully you'll avoid these kinds of mistakes. More like something like that. There we go. So place semicolons properly. Let's do a quick exercise with what we've learned so far. Let's write a program that reads decibel levels from the user and gives the user a description of that sound level based on the following. So 0 through 60 is quiet. By the way, decibel levels, that's sound pressure. Decibel levels don't exist in a vacuum. You can have negative pressure, but that's only relative pressure. So there's no such thing as a negative decibel. You can also have negative frequencies, noise canceling headphones. They cancel out, but that's frequencies. That's not going to be decibel levels. A decibel level is a measure of the loudness of an object, of a sound. Basically, compression waves in air at 1 atmosphere or whatever it is. So 0 through 60 is pretty quiet. 61 through 70 is conversational, like if we were 6 feet away, social distancing and talking. 71 to 110, that's what I am right now, probably in this room, so that everybody can hear me in the back, somewhere in there maybe, probably on the lower end. 111 to 194, dangerous. And what do we do about negative values, which don't exist as far as decibels are concerned, or values that are greater than 195? Right? I don't know at which point decibels become fatal because compression waves can be fatal, like in an explosion. But certainly we could put that in there. We could research that and find out what the fatal decibel level is or something. But let's go ahead and write this program here. So I'm going to go ahead and go over to my IDE, and I'll create a new file. What should I call this? Okay, exercise.c. Probably just like variable names, I want to give this a bit more descriptive name, because eventually I'm going to have exercise, 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 right? It's also not a good idea to label your stuff hack 1, hack 2, hack 3. In fact, we tell you the file names that you have to have in order to hand in and have the hand in accept. Let's go ahead and give it something more descriptive. Sound.c or decibel.c, if I remember how to spell it. Is that right? Decibel. Yeah, that's right. All right, great. Let's open that up. All right. What do we need first in any program? Documentation, exactly. We want all those documentation points in our hack. Documentation is 2 or 3 points, which makes it worth about 10% of your grade for all of your hacks. So me, yay. A date at least, 08/31. This program reads in a decibel level from the user and gives a human readable description of it. That's good enough. Right? What do we need next? Includes. I don't want to have to write my own standard library stuff. stdlib. What else do we need if we're going to be doing input and output? stdio.h. What do we need to do if we need math stuff? Math.h, but I don't think that we're going to be using many math here. Right? We're just going to be reading in a value and then printing out a bunch of stuff, okay? Or printing out one of these 4 things. So let's go ahead and start. Int main, int argc, char argv. At this point, you could probably have like a template, C template program here, and cut and paste it and just, you know, change what you need. Okay. So what's the first thing that we should do? Let's prompt the user for input. Oops. Printf. Please enter your decibel level. All right. We're probably going to want a value to store that in. So int decibel, right? Good variable name because that's what it represents. If I just had x, probably not a good variable name. All right, well, I'm into brevity and all that, yeah. D, right? Probably not a good one either. What does that stand for? Distance? Does it stand for, you know, what? You're not paying by the character. So if you're not into that whole brevity thing, man, go ahead and go with decibel. Right? Definitely much better. Right? No Lebowski fans? All right. All right, so what do I do next? Scanf, and I decided on an integer. What's an alternative design decision that I could have made? A double, right? Because you could have 50.5 decibels, right? Okay, I'll just go ahead and support integers. That's my design choice here. I'd go back, if this were an assignment, I'd go back to the assignment and say, well, what are the possible inputs here? They didn't specify, so hey, dealer's choice. Oh, they did specify. I need to go ahead and conform to that specification. If this were real life, right, you would have what's called a requirements document. That requirements document tells you exactly what you need to support. Here are some use cases. A user enters in 50.5 decibels. Aha, that must mean that we have to support double values. Or a user enters a decibel, another requirement or specification document would be that all decimals are whole numbers. Oh, okay, well then I only need to go with an integer, right? If it's unclear, then you go back to the people who put together the requirements document and the specifications document, and you say, I need some clarification on this because I need to know what I need to support, right? This is how things work in real life. Or you could just be a jerk about it and say, well, they didn't specify, so again, dealer's choice. And when we ship the product and it doesn't work because they didn't put in the specifications, that's not on me, that's on them, right? Who cares? I'm done, I'm going on to the next project. So that's why it's absolutely essential not to only write good code, but to also have good specifications, good requirements, right? And there's an entire, not field, but There's a small a branch of software engineering called requirements elicitation. Right? It's just requirements gathering. They needed a fancy word to make it sound fancier than it was, of asking people what do they mean by stuff. So they had to elicit stuff from people. Right? All right, so I chose to go with an integer, %d, and decibel. Is that correct? What magic do I need? Ampersand. Now I can check if the decibel is greater than 0 or equal to 0, or decibel is less than or equal to 60, then I will print out, what was it, quiet? 0 to 60 is quiet. Is that correct? So let's think about this. Let's do some ad hoc in our head testing here. The decibel is 30. That's certainly greater than or equal to 0. Okay. It's certainly greater than or less than or equal to 60. So yeah, it'll print out quiet, right? What if it is 90? It's greater than or equal to 0, so that's true. It's not less than or equal to decibel, so that's false. True or false is true. So this doesn't look right to me. What should I have here instead? Ampersands. And if it's between 0 and 60, then go ahead and do this. Now you can go ahead and stylistically change this less than or equal to decibel 0, and so that it looks a little bit better. Okay, that looks a little bit better because now I've got my range, my lower range on the left side, my higher range on the right side. That looks a little bit better. Okay. All right, the next one. What was it? 61 through 70, conversational. So if 61 less than or equal to decibel and decibel is less than or equal to, what was it, 70? Then print out conversational. There we go. Does that look right? Design-wise. Certainly if it's 0 through 60, only quiet will be printed. If it's 61 through 70, only conversational will be printed. Only one of these things will happen. But syntactically, is it possible that both of these things could happen, or neither of these things could happen? Well, it's certainly possible that neither of these things could happen because I'm not done yet, right? I've got other stuff to do. But does this look right? Exactly one of these things should happen. If exactly one of these things should happen, should I have two independent if statements? Probably not. What's a better way of writing this? Else if. Else if means that they are going to be mutually exclusive, period. Right? Syntactically now, exactly one of these things can happen. All right, any questions? Okay, just shooting it back and forth on YouTube. All right. Okay, well, let's go ahead and continue here. Else if 61. Let's see. 71 through 110. So 71 loud through 110. Okay, good. Copy pasta, copy pasta, copy pasta. Should I continue copy pasting? Else if, and let's see, 110. What was the other one? 194. There we go. All right, and that was what? I forget. Dangerous. All right. Okay. I just did a bunch of copy pasta. Copy paste, copy paste, copy paste, and change the values. Did I get it right? What happens logically? What happens when when I've got a decibel level of 110? It's both loud and dangerous. Okay. So don't copy pasta. That introduces errors. So Not that you have to type every single character, but you do have to be cognizant of every character that is typed. And you have to make sure that you're doing it correctly. If you can very easily get yourself into big trouble if you just cut, paste, and change, but then you missed one of those. Okay? So be careful. Else if, and then this would be like, what, 111, right? And else if, now what? Else if decibel is greater than 195. There we go. Then we'll print f unknown. There we go. All right, let's go ahead and test this out. Decibel. Oops. Return 0. There we go. Enter your decibel level. What should I try first? 30 is conversational, right? Or 30 is quiet, right? Okay. What else should I try? What are some edge cases or corner cases that I should try? Let's test that entire range. Well, I could test everything, right? All right, we'll go ahead and go with 0. Okay, that's quiet. Again, 1. Okay, that's quiet. 2. Okay, that's quiet. Do I need to keep doing this? Probably not. Good testing means that you've got good code coverage, meaning that you should probably test enough to make sure that each one of these intervals is giving you what you expect. So let's go ahead and test the edges of each one of those intervals. I already did 0, and I know that that's correct. Let's do something that's smack dab in the middle. 30, we already did that one, and it was correct. Let's do something that's on the other edge of that interval. 60. Quiet, okay. Let's do something that's on the other edge of that other edge case. 61. Okay, conversational, great. What's another one that I should probably test? 195. Well, let's test one less than that. 194, because 194 is supposed to be dangerous, right? Okay, good. Now let's test 195. Nothing? Is that what we expected? Over here with my code, I expected it to print out unknown. What was my mistake? Less than or equal to. Oops. Equal to. There we go. Great. Okay. Okay, good. I'm trying to think of the other intentional error that I want here. Otherwise, so what's another edge case that I probably want to try here? Can you have negative decibels? No. So, but you shouldn't be printing nothing. So what else? What is it necessary if I want to treat both of those the same, that a negative value is unknown and 195 or above is unknown, then what could I do to change this condition here? I could make that my default. Any other value that's not taken care of by all this stuff up here is going to fall to this last one. It's called fall through. This is not true. This is not true. This is not true. ... until you get down to an else, and then okay, well then this takes over. All right. Now when I do this, come on. Okay, come on. All right. 195 is indeed unknown. Negative 65 is unknown. And now it will always print something because I have this else statement down here as a final default. Let's clean it up a little bit. Okay. Think about the edges here. If I check at most 60 up here, do I need to check that it's at least 61 up here? No, why? Otherwise, if it's less than 60, this would have taken over. Forget about the negatives for a second here. If this were less than 60, this would have been true, and this would have printed, and the rest of this stuff would have been skipped. So if I want to simplify my code a little bit, I can go ahead and take out this lower interval because I know that it's at least 61 or more. I can do that with all of them. There we go. All right. Regression testing. A regression is that you go in and you make a change to improve code or to fix another bug, and you go back and test everything that you tested before so that you can see if there is a regression, that the code actually has a new bug. By fixing one bug, you've now caused 3 more bugs, right? That's a regression because you've regressed back to an earlier stage. Like in evolution, you know, you evolve to a higher plane of being or whatever. You regress means that you're de-evolving, right? You're taking your code and you're making it worse. You're regressing your code. So let's go ahead and try this out. What are some of the edge cases I should try? 0. Okay, quiet still. 30. Okay, yeah. 60. Still quiet. 61. Still conversational. 195. Still unknown. 194. Still dangerous. What else should I try? Negative 65. Conversational. All right. What happened? Let's go back up to my code here. So negative 65. Is that in my interval here? No. But by taking out that lower interval, now this one is checked, and decibel is negative 65. Well, that's certainly less than or equal to 60, which is why we get conversational. No, that's wrong. So what's one fix that I could have here? I could put all the code back to the way that was. Or, yeah. If it's less than, okay, handle that corner case separately. If decibel is less than 0, then printf error. Cannot have negative decibel sounds. Or whatever you want to print. Else if, and now I can take out the lower interval on that as well. And now I'll have a unique error message. Rather than both negatives and 2 high values being unknown, now I have a more descriptive error message. You can't do that. I don't know about these, but I certainly know about these. In fact, you can't have negative sounds or negative decibel levels. Now let's try that out and make sure that it works. A dot out. Now what do I have to do? I have to go through and test every single thing that I just did before. 0. Okay, great. 30. Okay, great. This is like play testing, right? Where the lowest of the low have to get the beta game, and then they have to test it and find all the bugs and report all the bugs. Hey, we don't have to pay beta testers. We could just have a free earlier release. Oh, no, we don't have to have a free early release. We could have a paid early release. And now you're paying us to do our beta testing. Thank you, right? Yeah, that's how it works. Right? So negative decibel level, negative 65. Error, you cannot have negative sounds. Right? Testing like this should be automated. You should only write this test once so that you can just hit a button and have the testing done all for you, all automatically. And then it'll have a report that says, hey, you passed 95 out of 95 tests. Great, you're good to go. Oh, you missed one. Or there was a regression. That change actually caused this test that was passing before to now fail. Automated testing. It's something we'll get into very, very soon here. Right? But otherwise, what I'm doing right now is called ad hoc testing. I'm just doing it by hand, which is not repeatable. It's very fragile. It's not something you want to do in practice. I think that looks pretty good for now. All right. And I will go ahead and cut and paste this so that you have it in your notes. Oops. There you go. Okay. All right. Short circuiting. This is like a miscellaneous wrap up, and then we'll do something else here. Consider the following logical statement. A and B. Okay? Now, what I'm going to ask you is, suppose A is true. Or, sorry, evaluates to false. And it doesn't have to just be a variable. In this case, I'm calling it a variable. It could be an expression. It can be whatever. Right? It could be a function that you call that returns true or false. Suppose that A evaluates to false. Does it matter what the value of B is? That's my question. Does it matter what B is? False and B is going to be what? False, no matter what B is, right? No matter what value B has, the expression is false. And that's because it's an AND statement. A logical AND means that both operands have to be true. Both operands have to be 1 if we want to call true 1. If one of them is false, then it doesn't matter what this guy is at all. He could be false or he could be true. The entire statement is false. Right? Consequently, the C and the vast majority of programming languages will not evaluate B. All right. It is skipped or short-circuited. So what is short-circuiting? In like not real life, but in electrical engineering life, short circuit. If you've got a circuit and you short it out, what are you doing? You're giving it a smaller cycle, I guess you would call it. Electrical engineers, anybody? No electrical engineers? This cycle here, it'll short out. So if this is the battery and this is the light bulb, and you've got a circuit between the two, the light bulb is shining. You short it out, that means that the electricity is now only going through this cycle right here, and now your light bulb is out, right? That's what short-circuiting is, and as far as code goes, it's short-circuited. It's not even going to evaluate your light bulb over here, right? So it's not even going to check to see if that light bulb is on or off. It's just going to ignore it because it knows that it can go on and say that the entire expression is false. Likewise, consider the following. A or B. And suppose A is true. Does it matter what B is? No, in this case, what? No. The expression is true regardless of the value of B. Right? Again, it's short-circuited. It doesn't even look at this, right? For the majority of cases, this does not play a big role. It is important if you are calling functions, right? So for example, let me go ahead and give you a full code snippet here, right? If A and some function of B, right? And then we do something. Right, there we go. So if A is false, is that some function ever called? Nope. So give me something important. Give me an important operation of a computer. I don't know, verify log, or some action. Write to the database, right? Some important action like writing to the database. If A is false, and we still want to write to the database because that second one should still be evaluated, is it going to end up happening? No, because of short-circuiting. So you have to be very, very careful here. This is true of the vast majority of programming languages. They use short-circuiting, and why do they use short-circuiting? Think back 50 years ago. If you could get away with a few, optimizing out a few CPU cycles, you did it. Right? We're not in that age anymore. You can waste as many CPU cycles you want, right? I mean, the typical poorly designed game or poorly implemented or poorly programmed game is wasting CPU cycles all over the place. Just get a TI 3080 now. Just get a TI 3080. Right? They announced the prices, right? 3080 and 3090s, yeah, yeah. I think the top of the line 3080 Ti was 1600. Okay, just get a faster. Just get a faster card. Get a faster. Yeah, just get a faster hardware, right? We're not going to make those programming optimizations for you anymore, right? Because they don't care. They live in a world where computing is basically free. 50 years ago, it was not free. 50 years ago, if you could get away without evaluating the second operand here, you did it because that made your program noticeably faster, right? And we're still living with it to this day. Why? Because of familiarity. It started in C, and it was propagated through many programming languages, and because it's familiar, programmers have come to rely on it for various patterns that they like to implement. So it's still happening today, and we're still using short circuiting. It's important to remember that. Okay. All right. Let's see. 1400. Oof. 3090 is 1600. Yeah. All right. So I thought I saw it. Oh, okay. So it's not official, but I mean it's as official as it could be. When you use an if statement, so a question online here. When you use an if statement with a logical and statement, do you need parentheses in them? Like, yeah, no, you do not. So the question here is, I'm going to go ahead and cut and paste it. Do you need these? So, question: do you need the parentheses here? All right, there we go. And no. Answer, no, it would be better to write this without the extraneous parentheses. But I would put in extra space there, extra white space, just so that you're not bumped up against that those parentheses. I'd also put white space in between all my operators. Space things out, right? If you shove it all together, yeah, a computer can read that. Computer's fine with that because the computer doesn't care about white space, but we humans do. It's way more readable to put in white space, and then you don't have to parse each one of those tokens. Imagine a novel where they didn't put in spaces, right? And you had to, yeah, it's still readable, but you have to parse every single word and find out where it ends, right? Say what? Yeah, the ultimate camel case. Good. Actually, you would want to do that in some instances. For example, JavaScript. JavaScript is not compiled, right? So what you can do, though, is you can minify it or uglify it. So what you can do is you can take JavaScript code, run it through a minifier, which will go through and take out all the extraneous white space, because you're sending it over the wire to be executed in a browser. You're not sending it over to a human to be read. So if you can save, even today, if you can save a few kilobytes in the transmission of a JavaScript file, you still do that. Why? Because it makes the web faster. But then, of course, if you put in 50 megs of spyware and adware JavaScript libraries, then it kind of defeats the purpose. But that's okay, because you can put on ad blocker and DuckDuckGo privacy essentials and what else do I have? Nope. uBlock Origin and Privacy Badger. And believe me, you need all of them. There are some things that slip through the cracks. I would highly recommend that you get them all. Right? Okay, so good question. Any others? No? Okay. All right. Okay, so kind of tangentially related to this. Remember all those pitfalls that we went through? And when I compiled The compiler didn't say anything about them because they were all syntactically correct. In fact, let's go ahead and take a look at an even worse program here. Linty. I'll tell you why it's called Linty here in a second. So let's try to walk through this program and see what it does. Okay, a bunch of variables. All right, fine. D is equal to A divided by B. Okay, fine. And then I print out C is equal to %FD. Okay, so I'm printing out C, which is going to be equal to A divided by B, which is 10.5 divided by 20. So that's going to be something. 10.5 divided by 20. Pull out your calculators and tell me what they are. Then I read in a variable from the user. Okay, fine. Then I print it out. Right? Then I do. If they entered 10, then I'll print out that it's 10. If they didn't enter 10, then I'll print out that I won't print anything, right? So else printf x is not 10. All right. It is %d and the line, and we'll go ahead and print that out. Okay. I create another variable called foo. Fine. If x is equal to 10, then x is 10. And then I do the final pitfall up here, foo, right? Okay. All of these are perfectly fine. Oops. All right. I shouldn't have done that. There. All of these are perfectly fine. There we go. Let's run it. Remember that it reads in x, so let's go ahead and enter in 10. Right? Actually, first, C is 0? What is 10.5 divided by 20? Okay, not 0, right? So there's something going on there. 10, segmentation fault, right? So what's going on here? Lots of errors, right? This is what's called lint, right? So trust me, this is my shirt is clean, but just because something is clean, does that mean that it's clean? Like just because it came out of the wash, does that mean it's clean? Now take a formal dress shirt, right? You wash it, you press it, maybe you press it. What does it still have on it? Potentially, lint. Right? Lint is little tiny pieces of fabric that are left on because the fabric gets rubbed up and then the little pieces get off there. So it's something you don't want there. That doesn't mean that it's not clean. It doesn't mean that your shirt doesn't work. It just means that it's a little bit dirty and you want to get rid of that stuff. So what do? You take a lint roller and you roll off all the lint. Right? It's just a adhesive strip that ends up pulling all the lint off. You have that in code too. You have something called a linter. Okay? So code may be syntactically correct. It may compile, but it may have errors. So what you want is a tool to tell you that, hey, that doesn't look right. That looks like some lint in your code. It's not an error. It may not be an error, and it may work perfectly fine. Lint are pieces of code that may look suspicious, though. And it may lead to errors, but are not syntax errors. So how do we tell GCC to be a linter for us? Right? A linter is a static analysis tool that looks for potential errors in your code and tries to report them, usually as warnings, because again, it's not an error. It's syntactically correct. It'll compile, it'll run, it'll probably give you errors. So a static analysis is an analyzer. It's not a compiler. It's something that goes through your code and looks for red flags. Whoa, that doesn't look right there. That looks like lint. You may want to take care of that. You might want to take a closer look. You take a closer look and you say, yeah, that looks bad. I need to go ahead and fix that. Or you take a closer look and, that's not lint. That's just a piece of dust. That can stay there, right? Or yeah, okay, it looks bad, but I actually need it because that's what my intention is, right? It's just a warning that tells you, take a closer look at this thing, okay? Static analysis basically is a tool that runs with anytime you hear the word static, it's at compile time or before compile time. Dynamic is when a program is actually running, right? So a static analysis tool looks at your source code and says, there's a problem here, there's a problem here. A dynamic analysis tool, like say a debugger or what's called a profiler that we'll take a look at later on, You can run those on a program as it's running to tell you certain things. Like, you've got a memory leak over here, or you actually you have a segmentation fault because you actually divided by 0 here. Stop and take a look at everything, debug this, right? You need to go back to your source code and fix this, right? So static analysis is done before you compile, okay? GCC can be used as a rudimentary linter. There are plenty of linters out there that you can use. I've got a little short list of them available on GitHub that I'll send out later today. Some of it some of it you're not going to use on a daily basis. Some of it you'll only use later on when we get into say memory management and memory leaks and stuff like that. But a really easy way to treat GCC as a linter is to turn on all warnings. That's not wall, that is warnings, all of them, right? And now when you do this, oh, now brightly lit here, right? There are a whole bunch of warnings here. For example, when I printed out C and I got 0, that's because it was a floating point number and I tried to print it out as an integer, or it was an integer and I tried to print it out as a floating point number, or vice versa. That tells me I've got the wrong types. I need to go back and make C a double, or D a double, excuse me. And in fact, maybe there's a disconnect here because C is equal to D. Okay, maybe I'm printing out the wrong thing there. Likewise, scanf, if you're reading in, what's wrong here? Scanf, what magic do I need? That ampersand, and now it's warning me about that, right? You're missing an ampersand. Don't worry about star for now. That's a pointer. We'll get to pointers later on. But at least you know that there's something wrong with that line. And you stare at it and you look at it long enough and you say, aha, I forgot the ampersand. Right? The if statement, right? Remember this? That was one of the pitfalls. This if clause has no guard, meaning it does nothing. Right? If x is equal to 10, do nothing. It's warning you about that. Note, this statement, but later, is misleadingly indented as if it were guarded by the if statement. Same thing here, right? That you've got an opening curly bracket that it noticed after that semicolon. You probably did that wrong. Warning, suggest parentheses around assignment used in truth value. Oh, yeah, that's an assignment operator. That's not an equals equals. I need to go fix that. Comparison of constant 10 with Boolean expression is always true. Hey, that's a tautology right there, right? It caught that other pitfall. Warning, expressions like the same thing here. Warning, do not have their mathematical meaning, right? This is not math. This is computer science. This is something different. Right? Warning, unused variable foo. That's not gonna cause a problem, but it does show that I've got a design issue. Why are you declaring this variable if you're not going to use it? Right? That leads. That's what's called a code smell, and we are all cognizant of smells now that we're wearing masks, or maybe we're not. We're just now cognizant of our own smells instead, right? And whether or not we've had a Tic Tac lately. I've not, but I didn't have a big lunch either. So code smells are things that stink, not necessarily rotten. Right, but they stink and they smell kind of bad. Maybe we want to take a look at that, right? Linters, it's kind of like lint, right? It's not something that means that it's dirty. It's just something that you don't want there. It smells. Let's go ahead and take care of it, right? By removing that variable. Unused variable C, unused variable Y. We probably want to take those things out. And understand that in your hacks, that is worth design points. Design is worth 5 out of 25, I believe. Right? Yeah, 5 out of 25. And you can lose a point if you have not addressed all compiler warnings. Because what we do is, on the grader, we use that WAL flag. Check the output. If you do, and in fact, you should use this in all of your compiling. If you don't use this, then you will not see, like before. Oh, it's all good, right? No, it's certainly not. Right? There are at least a dozen warnings there that I need to take care of. Some of them are innocuous, like unused variable names, unused variables, but a whole heck of a lot of them are definitely not innocuous. They are going to cause problems and errors in my program. Okay? So the W-all flag, use it. Remember what the -lm flag, what is that for? Linking in the math library, right? Not going to be an issue in this case because I'm not using the math library. Okay? Any questions online? Nope. All right. Okay. Any questions in here? So once again, oh yeah, go ahead. I don't think so. Let's see. GCC W-all. All one word too, no space. Decibel. Looks like it likes it like that. Or like that. The only one that's persnickety is that -lm. And I've never been able to find a definitive answer why the order of the flag matters on some platforms. Generally, flag order doesn't matter. Except for if you are linking stuff in, it does matter that you want to link in this library, then this library, then this library. That order may matter because there may be a conflicting definition in those libraries, but there's no conflicting definition when you've got one library that you're linking in. Okay? Okay. No questions? All right, then. When we come back on Wednesday, we'll start on the next module, which is loops. But remember that, that this week, it's just conditionals. Now, tomorrow in your lab, it's going to be conditionals. On Thursday, your hack is going to be conditionals. No loops just yet. All right, good luck with your hack tonight. Your reading 3 was due at 5 o'clock earlier. So after you get everything for this week done, make sure that you're starting on that reading for loops in Zybooks. Okay? All right, and no questions online, it appears, so have a good rest of your day.